Hello everyone. In today's lecture, we will learn how to determine the moment of inertia of any section. So in this question, they have asked us to determine the moment of inertia along the horizontal as well as vertical axis which is passing through the centroid of the section. Now if we see this diagram, this particular section is symmetrical about y-axis. That is, it is like the mirror image of this section on this particular line. Correct? So that's why we can say that the centroid in the x direction lies exactly on this line. So this distance can be determined by dividing this 400 divided by 2. So, or you can also take the reference axis exactly on this centroid, and in that case the x bar will be 0. So the given symmetrical about y-axis, therefore the centroidal y-axis coincides with the reference y-axis, right? That's why x bar can be told as 0. Now the moment of inertia about the centroidal x-axis, we have to determine that is given by I11. So let us say that this section we are taking the I11 here. Let's call this as 1, 1. Okay, so we are determining moment of inertia I11. So that's why I11 is equal to I x bar plus a y bar square. So this will be equal to, so this is from the parallel axis theorem which we have derived. This will be summation of I x bar plus summation of a y square. So from this expression we can say that I11 is equal to, or I11 minus a y bar square is equal to I x bar. So these two relations are very important. So first we will determine I11 using this summation of I x bar plus summation of a y square, and from this we can calculate I11 minus a y bar square is equal to I x bar. So these two relations are very important which we have to remember. Also in this case x bar is equal to 0. Correct? So that's why we need not determine the other moment of inertia. So we will discuss that. So this is our section. So looking at this section, we will try to write the details. Okay. So let us take component 1. So let's take component 1. Now which is component 1? I can say that my component 1 will be this. This is first component. So this is second component, and this will be third component. This I am simply assuming. Now we have to calculate, if you see in this tabular column, I have to calculate area y, ay square, ix bar and iy bar. Area of each components will calculate. Y with respect to the axis 1, 1 which we have considered, that we will calculate. Ay, that is area multiplied by y. Similarly a into y square and ix bar. So here if you see, there are rectangular sections. So for a rectangular section we know that ix is equal to bd cube by 12 and iy is equal to db cube by 12. Now using these relations and the formulas which we have learned to determine centroid, we can calculate or fill in this entire tabular column. Now area of the first component, if you see, it is 400 into 50, that is length into breadth. So if you calculate this, you will get 20,000. Now y, now how to calculate y of this component? So you have to add 75 plus 600 plus 50 by 2, that is the centroid of this component is lying here. You have to determine the distance between this point and the reference axis, that is 1, 1 in our case. Correct? So that's why we have to calculate the distance between these 2 points. Now it will be 75 plus 600 plus 50 by 2. So let's fill in that. 75 plus 600 plus 50 by 2. If you simplify this, you'll get 700. Now multiply these two, area into y. So you'll get something like 14 into 10 power 6. So that is millimeter cube. Now A into Y square. Square of 700 into 20,000. So you will get 9.8 into 10 power 9. So I am simply writing it. I have calculated it already. So Ix bar is what? Our BD cube by 12. B is in the X direction, that is 400 into D cube. D is 50 cube divided by 12. So this will come to around 4.167 into 10 power 6. So similarly, Iy bar will be dB cube by 12. D is 50 into 400 cube divided by 12. So this will be around 266,666,666.7, something like that in decimals. So let's move on to the second component, right? So which is our second component, that is, it is the rectangle which is lying in the Y direction. So this is our second component. So its area will be 50 into 600 and Y will be, so its centroid will be at a distance of what? 600 by 2, that is somewhere here. But you have to reach from the reference axis here. So it will be 75 plus 600 by 2, and in the similar way we have to write its AY square, Ix bar. So when you come to Ix bar, it will be 50 into 600 cube by 12 and Iy bar will be 600 into 50 cube by 12. So similarly for the third component, again area will be 200 into 75, and if you want Y, it will be directly 75 by 2, and again we have to calculate AY square. When it comes to Ix bar, it will be 200 into 75 cube by 12 and Y bar will be 75 into 200 cube by 12. Now I have just filled in all the required data here, that is the calculations part. So the next step will be the summations of all the things. So whatever we need, so we need in the formula, we have to just sum it out, right? Area, the summation will be 65,000 and the summation of Y is not required for us. So summation of AY, it will be 25.81 into 10 power 6 and summation of AY square is around 1.404 into 10 power 10 and summation of Ix bar will be 911.197 into 10 power 6 and similarly summation of Iy bar is equal to 3.22 into 10 power 8. So these are the summation values. Now let's go back to our formulas which we have written to determine the moment of inertia. So if you see here, we have calculated all these values. Now we'll have to simply simplify. Now the next step is we have to calculate Y bar, right? Because we have this Y bar square here. So Y bar is simply equal to summation of area into the centroids of each components divided by summation of area. This we know from the concept of centroid. So if you simply substitute the values of summation of AY and A, summation of AY and A from this sheet here, so you will get Y bar to be 397.108 mm. So that is the Y bar of the section which we have considered will lie at a distance of 397 from this reference axis, 397.108, right? Now let us substitute in the formula here. So we have to determine I11 first. So we have summation of Ix bar, the value is known to us, plus summation of AY bar, right? So here we have the values. Summation of Ix bar will be 911.197 and summation of AY square, so addition to that 1.404 into 10 power 10. So if you substitute that, you will get the value of I11 to be 4.691 into 10 power 9 millimeter to the power of 4, and if you want I bar x, that is what? The centroid in the x direction, I x bar is equal to I11 minus a y square, right? I11 we have calculated, a is known to us, and a is nothing but the summation of all the areas, right? So area into y bar square. So y bar we have calculated to be 397.108. Now if you substitute all the values, you will get I x bar to be 4.691 into 10 power 9. Sorry, there is a small correction here. This I11 value is 1.495 into 10 power 10. So I11 is that, and I x bar is 4.691 into 10 power 9 millimeter to the power of 4. Now if you want I y bar, because the given section is symmetrical about y-axis, so we can directly say that the summation of all the moments in the y-axis, that is this I y bar, that is 3.22 into 10 power 8, you can directly tell that the moment of inertia of the given section about centroidal axis as 3.29 into 10 power 8 millimeter to the power of 4. Let's move on to the next problem. So the given section is looking something like this. It is a C section. So here if you see, the given section is not symmetrical about both x and y axis. So again we have to determine the moment of inertia, and also they have asked us to determine the radius of gyration. So we will see how to calculate that also. So we have to determine the moment of inertia about its centroidal axis, that is centroidal axis will be xx yy. So this, let's say this is the centroidal axis. So we have to determine this G or the centroid. So where exactly is it? So for that we have to assume our reference axis as the leftmost and bottommost part, which we used to do in determining centroid. So let's say 1 1 is the reference axis in x direction and 2 2 is the reference axis in y axis. So again, if we want to solve this problem, so we'll have to divide the given sections. So if you divide the given sections into its components, so let's call this as the first component. So I'll take this rectangle as the second component, and I'll take this rectangle as the third component. So we'll have to determine all the required components for these particular shapes. Now let us take the first component, that is number 1. So we have this rectangle, correct? So this is the rectangle. Its area will be 120 into 10. That is simple. Now we have to determine its x, that is centroid in x-axis. That is, so this is the reference axis which we have to look. So it will be directly 120 by 2, right? So it will be 120 by 2. Similarly, its y will be lying here, but the reference axis is here. You need this distance from this centroid and the reference axis. For that we can say that 120 minus 10 by 2. 120 minus 10 by 2 will give me the centroid of this rectangle. So you'll again have to calculate ax, ay, ax square and everything. So for the first component I'll write here. So it will be, area will be 120 into 10. So you'll have to simplify that. X will be 120 by 2, which is 60, and y will be 120 minus 10 by 2. So you'll also have to calculate ax, area into x, area into y, area into x square and area into y square. So this square. So you'll have to also calculate these components. So if you come to the second component here, so again its area is 12. So this is 12 mm into, so the whole section is 120. So if you remove this 10 and 10, so this particular rectangle will have a height of 100 mm. So its area will be 12 into 10 and its y bar will be again 12 by 2. and that will be x by 2, and similarly y bar will be 120 by 2, x bar will be 12 by 2, and y bar will be 120 by 2. Or if you want to remove it, 120 minus 10 here, so you'll again have to add this 10 mm and calculate that. These things you know how to do it, so calculate that. So you will get y bar of this component, and also calculate ax, ay, ax square and ay square. Similarly, for the third component, area is 180 into 10, and x bar will be 180 by 2 and y bar will be 10 by 2. And similarly calculate ax, ay, ax square and ay square. I have just computed all the values. So these are the summations: 4200, ax is 2.41 into 10 power 5, ay is 2.19 into 10 power 5, ax square is 18.94 into 10 power 6, and ay square is 20.235 into 10 power 6. Now also you need to calculate ix bar and iy bar, that is bd cube by 12 and db cube by 12 for each of the components. So, and also we require its summations, right? So that's why we have computed that 1.025 into 10 power 6, and iy bar is, summation of iy bar is 6.3162 into 10 power 6. Now we'll just have to substitute all the values in the formulas which we have written. I11 is equal to summation of ix bar plus summation of ay square, that we have just computed. And also by using this I11 calculate ix bar. For this you need y bar square. Always remember ix bar will have y bar, so that is important. So ix bar is equal to I11 from this value, and ix bar is calculated by I11 minus a into y bar square. Y bar is again summation of ay divided by summation of a. If you square that and multiply by area and subtract the whole thing by I11, you'll get ix bar. And the final value of ix bar you will get as 9.841 into 10 power 6 millimeter to the power of 4. I'll just also give you these values. I11 is equal to 21.26 into 10 power 6 millimeter to the power of 4. Similarly, in the other directions, that is I22. So if you compute, you will get I22 as 25.2592 into 10 power 6 millimeter to the power of 4. And by using this I22 and x bar values, you will get the y bar as 11.4077 into 10 power 6 millimeter to the power of 4. Now we have computed the first part of the question, that is ix bar and iy bar, that is 9.841 and 11.4077 into 10 power 6 millimeter to the power of 4. Also we have been asked to determine the radius of gyration. So we know the expression for radius of gyration as kx is equal to square root of ix bar divided by a, and in the other direction ky is equal to iy bar divided by a. So if you substitute the value of ix bar here, that is 9.841 into 10 power 6 divided by the area, that is summation of area, which we had computed that as 4200. So substitute that under root, and also ky is equal to square root of iy bar, that is 11.4077 into 10 power 6 divided by 4200. So if you solve them, kx will be 48.406 mm and ky will be 52.11 mm. So these are the radius of gyration in x and y direction. Also sometimes it will be asked to determine the least radius of gyration. It simply means that the minimum of these two. So if you see, kx is the lesser value among these two, that is 48.406. That's why we can say that the least radius of gyration for this particular section is 48.406. Thank you.